Welcome to Study Loop.
Hello and welcome to Conceptual Physics, chapter number 9, problem number 102. So this problem asks us to discuss how if we change the diameter of both the Earth and the Moon, how that would affect our tides. So what you need to consider is how an increased radius or diameter would affect the gravitational pull of both of these objects. So first with Earth, if you have an increased radius, that would mean that the gravitational pull, the force due to gravity, is going to be a lot less on that surface, right? We have that inverse square law that was what gravity follows by. So um, if we had a much larger radius on Earth with the same mass, that would mean that the moon's gravitational pull on Earth and therefore the tides would be much more have much more influence. So if Earth's radius was much larger than it is now, then our tides, our high tides would be much higher and our low tides would be much lower. And so for the other part of this question, it asks us if the moon had a change in its diameter, how that would affect tides as well. And simply put, that it won't affect it at all. As long as the moon has the same mass, the gravitational pull is going to be the same because the moon itself may have a smaller gravitational pull on the surface. However, the distance between the moon and the Earth, as long as that stays relatively the same, then the gravitational pull will also stay relatively the same. So that's the answer, is that we're going to have much higher tides and much lower tides if the Earth was bigger than it is, and there will be no changes in our tides at all if the moon is much bigger than it is.